Rahim. This is a question October 1343 variant. And question is there are two masses, mass A, mass B. You can mention clearly, mention here. And height of the A particle is h, height of the B particle is 1.6. B released, it means they're moving. And what is the moving style? He's by move. B reach the floor, it means B will move downwards, heavy particle, and A will go upward, lighter particle. We got from here. And this line is the most important line. I'm underlining this one. So A continues to move up, to move vertically upwards until it reach height of 3 meters above the floor. Above the floor. It means I will show this diagram to you. That situation number next, which can be here. Okay, well, I make it again here. So B is here, will fall down. How much down, students? Common sense, 1.16 meters. Very clear mention. And I suggest as a teacher, best technique for you, you have to draw this kind of diagram. If you draw, question become easy for you, inshallah. And if you're lazy, you will not able to understand. B will fall 1.6 meter. A will go upwards 1.6 meters. I believe you got the point what I'm saying. Okay. Now, afterwards, what happened? Do you think it will stop here? No. I given a lot of time examples that whenever B will hit the ground, A will go up. When it will stop here, but this particle will not stop here. It will go slightly upward. This motion is called motion due to inertia. Okay. And I hope so you got idea. And now I'm reading the statement again. A continues. Continuous means what? This is called continuity. Okay. This is called continuous motion. Vertically up, reach a height of 3 meters above the floor. So can I say, students, look, I'm showing a blue color line, and I believe inshallah understand. So this height is 3 meters. And I believe you got a point very clear what I am saying. So this distance is 3 meters from ground to the top. I hope so clear. Now it is a very clear sense. How much this students 1.6? How much this 1.6? How much this I don't know. So let's say H. Can I say? Can I say students? So can I say students? This is a 1.6 plus 1.6 plus H equal to 3. Okay. I think now you got a clear picture. So I use this diagram to get the H. So free fall, a motion upward. I talk about this one. So I'm writing it now here. I'm writing a title for the B, for A, sorry, for A, no. Wait a minute. B is lighter. Yeah, A will go up. Yeah, A will go up. For A, inertia motion. I give title for me or teacher for examiner even. So now very interesting part is there. So I got a height. Height is 3 meters minus 1.6 subtract 2 times. And wait a minute. It is a 1.62 time. It give you 3.2. Wait a minute. Wait a minute. Oh, sorry. This is a H already used here. So let's say this is H1. H1. Okay. H1. And what is the basic criteria? This particle not starting from the same height. No, sorry. This particle is starting from slightly below. But it means this. I have to show this idea once again. 1 minute, please, students. I will drag it and I will show it because this particle is 1 minute. Okay, is like this. Okay, is like this. And this diagram I make here. Okay. And it means this, and this I'm erasing. This is correct, not wrong at all. This I'm erasing, and this is a 3 meters shore. And this is small, this gap below is small h. From where I got it, it mentioned here. And find a speed, okay. Now we can see clearly, students, it means A, yeah, first of all, I can find out the, because start moving. So let's start that one. How we can start that one? So A, look at here. The A particle weight, how much, student? 0.2 newtons. P particle weight, how much? 6 newtons. Then tension towards pulley, that is for sure. Now I'm writing for B. What is B data? Because according to situation, this A will go up, B will come down. So B will come down. So B will come down as we know. So 6 is bigger force. So 6 minus tension equals to MA. And for A, I can make an equation, tension minus 2 equal to MA. Now I think I'm going close to my answer. There's a, not answer, sorry, 0.8 A. 0.8 will divide, and as 0.8 will divide, so A is a 48, 5 to 40, 5 meter per second square. So it means acceleration is a coming here with us is 5 meter per second square. Okay. Now see, um, starting speed zero we have, here, and acceleration we have here. Okay. And but H I don't have, no problem. I can do one thing. What I can do, using this B component, I can find the last velocity. Okay, last velocity. And last velocity is very important to know here. So I want to find out B will hit the ground with what speed. So I change the plan and I'm going for B first. For B particle, I'm going to do it. Naturally, you can say U0. Last velocity is my target. S is 1.6, which is given by him. I will must utilize it. And acceleration just before hitting is 5. And now I'm finding 2as is equal to v squared minus u squared. And acceleration is a 5 and s is 1.6. And last velocity question u0. And I got it 10, 6, 1, 16. So 16 would become 4. This is 4 meter per second. So it means just before the hitting, the velocity is 4. Now I will give you an idea. Look at here. My question, what is it just before hitting speed coming here? Velocity is 4. All you have, if you agree with me. And the same velocity at this moment. So for moment of inertia, this V will become U here. We discussed last class this concept, and I'm discussing the same thing here. This and last velocity 100% zero because it will stop here. And gravity going upward always negative 10 here. Let me write again, negative 10 here. Using this data, I can find out this H1 easily. I repeat my words. Using this data, I can find distance very easily. And when I have this distance, full is 3 meters. And then I have this distance, then I can find H easily. So let's start. Now I talk about this one. So for a particle, free fall motion upwards. What is title? For a inertia. I just write a word inertia. Students understand and teacher understand even. Inner. If you will write this exam, you will understand what you talk about. Now, U is this becomes U, 4. This 4 become U. And going upward, last velocity is 0. And S height is my target. And gravity going upward, negative 10. So let's apply V is equal to U plus GT. V is 0, U is 4, gravity negative 10, and time is my target. 4, 10 equal to 4. Oh, sorry, wait a minute. I need to find height. Why I use this formula? Sorry for students. I have to use S is equals to, I think you can use the other one, 2as, that is easy. 2as is equals to v square minus u square. 2a is -10, h is my target, h1 I given name h1, and last velocity is 0, u is 4. So h1 becoming what? -16 by -20. And height 1 is coming here 0.8. I just recheck. 16 divided by 20, yes, 0.8, correct. So 0.8 meters height. It means I go back this diagram, and this is 0.8, this is 1.6, and this h we can find easily because add them all equal to 3 meters. So now I can say very clearly, so h1 is equal, h equals to 3 minus 1.6 minus 0.8. This give you 2.4 because 0.8 one time and 1.6 second time. It give us 2.4, and h which you're looking for is 0.6 meters, which is my target because he was asking find the height h. You saw, students, so cleverly he deal and so cleverly given the data. Students normally never understand what this statement means. So it means with a maximum height gained by the particle, make sure it will go due to inertia. This inertia motion we must add. So this distance plus this distance plus h give you 3 meters. So I hope so. The point is very, very clear, and we have done the question.